Ladies and gentlemen, please welcome to the stage Glenn Atkinson.
Well, good afternoon to our afternoon session of Connect, main panel, Securing the Future of the Data-Driven Innovation and Competition in the Connected Vehicle World. We heard this morning from Neil some really exciting things that are going to occur in the very near future in our connected space. One of the things that we need is we need access to the data, and to do that, we have to ensure it's done securely and with considerations for privacy. So I've got an expert panel coming in, so please welcome the panel. Stefano. Hi, Deb. Craig. Dan.
I guess.
Dirk.
Yeah,
Thank you.
He's at 1:30. Okay.
So I'd like to begin by introducing our distinguished guests, and external and internal. And I will start with Dr. Dirk Schlimm. Dirk is the Executive Vice President and a member of the GEOTAB Advisory Board since 2010. Dirk's focused on various aspects of risk management. He helps structure and negotiate legal and policy frameworks for data privacy, data usage, data access. And in addition, Dirk works with GEOTAB's European business development team and is GEOTAB's Chief Privacy Officer. Dirk previously was a member of the senior executive team at Husky Injection Molding, and he holds a law degree from Bonn, Germany, and a doctorate in comparative law. And next, I'd like to introduce Dr. Dan Massey. And Dr. Massey leads the development of cybersecurity program at the University of Colorado Boulder. It includes curriculum at both the graduate and undergraduate level and engagement with industry and government to solve critical problems. Prior to joining Colorado University, Dr. Massey served as program manager for the Cybersecurity Division, Science and Technology Directorate, U.S. Department of Homeland Security. And their mission is to contribute to enhancing the security and resilience of the nation's critical information structure and the internet. And I can personally say one of the projects that I got involved early while Dr. Massey was there was with a Uptane project to develop an open source, secure, over-the-air update with the University of Michigan and New York University that was made available for all vehicle manufacturers. And recently, Dr. Massey has been to Brussels and was invited to the EU Parliament to testify on the benefits of open systems for security in vehicles. Welcome, Dan.
Thank you.
And next, I'd like to introduce Craig Smith. We've known Craig for several years now. Craig leads the Rapid 7 cyber transportation, and that's, as they say, planes, trains, and automobiles, and also ships. Rapid 7, for those who might not know, is a global cybersecurity research company with technology, services, and reach that drive vulnerability management application and security, incident detection and response. And they cover more than 7,000 organizations across 125 countries and includes 52% of the Fortune 100 companies. Smith is also founder of Open Garages, a distributed collective of performance tuners, mechanics, and security researchers and artists. He's also the author of the Car Hacker's Handbook, and for those that have been involved in car hacking and research, that's sort of one of the Bibles. He's developed many open source utilities to teach CAN bus protocols to students, as well as security penetration tools. So welcome, Craig.
Thanks, Glenn.
And next, we've got Ted Gill. And Ted Gill is the automotive lead at the World Wide Web Consortium W3C. He's also research staff at the MIT Computer Science and Artificial Intelligence Laboratory CSAIL. So the World Wide Web, of course, is the demonstration of open source, where any device can connect to any IP address. And Ted is heads up and leads the automotive part of the World Wide Web. As well, Gill is research staff at MIT Computer Science and Artificial Intelligence Laboratory, known as CSAIL, and it's the largest research laboratory at MIT and one of the world's most important centers of information technology. CSAIL has played a key role in the computer revolution and development, such as time sharing, massive parallel computers, public key encryption, mass commercialization of robots, and the World Wide Web. So, welcome, Ted.
Thank you.
Perfect. And at the end, we have Stefano Peduzzi. He's the director of GEOTAB Europe. Many of you are probably familiar with Stefano. He's an internationally experienced IT executive and manager with extensive knowledge of information technology market. The combination of both a theoretical and technical background and has a deep business expertise, and it allows Stefano to support the growth of GEOTAB, the European team in particular, from the ground up. Stefano has a degree in management engineering and over 15 years experience in telematics and fleet management, automotive CAN, OBD2, business intelligence, and system integration and mobile technologies. And myself, Glenn Atkinson, I'll be moderating the session today. I've been with GEOTAB since 2014. I've got about 35 years experience in product safety and design for safety and product liability litigation experience. And one of my key functions with GEOTAB is external collaboration with industry associations to advance cybersecurity and product safety for GEOTAB and for the industry. So I'm thrilled to have such a highly qualified panel of experts to discuss the most important aspects of the connected mobility ecosystem, and that is open access to the vehicle data that addresses the key issues of security and privacy. So let's kick things off without further ado, and I'll start with you, Dirk, if I can.
Sure.
Thanks. And Dirk, how did GEOTAB get involved with neutral vehicle? And maybe describe a little bit about neutral vehicle.
Sure, Glenn, I'd be happy to. We heard this morning that the digital economy runs on data. We heard that from Neil, we heard that from Tony Seba, and interesting to me that for the last almost 20 years of GEOTAB's existence, the access to data, the fact that a fleet, be it a small, Neil spoke about the ice cream truck this morning, or a global mega fleet could have access to the data that is generated by their vehicles was taken for granted. And so an industry has developed where commercial fleets, small business fleets, large fleets, government fleets run on data, and they expect to be able to do so. Then 3 years ago, really something happened where that could no longer be taken for granted. There came the idea that plugging in a device into the OBD is maybe not secure. Maybe it violates privacy. And as we looked into that, we also started to realize that now that many more players start to understand the value of data, there is an attempt to benefit, to capitalize on that data. And in particular, what came out is that some vehicle manufacturers, especially in Europe, but also here, said we would be the best provider of the data, and we should maybe be the exclusive provider of the data. And so we have a sort of data supply management. And there were proposals being made how that would work. One of them is namely the extended vehicle. And what that would mean is that the data can only be accessed via the vehicle manufacturer. Now, that comes with a number of problems, because if you take out the competition, that has an impact on data quality, that has an impact on pricing. We looked at some of the proposed agreements that restricts what you may be able to do with data, and especially if you run a mixed fleet, you're not able to do that with data provided by a single vehicle manufacturer. There were also some legislative proposals out there to confine the data supply to just the vehicle manufacturer. And of course, that caused all kind of alarm bells with fleets, with our customers. And so we got involved in this topic. And one of the areas of involvement was lawmakers, and proposals that were put forward to have this exclusive data supply from the vehicle manufacturer. And a concept was presented that was known and is still known right now as the extended vehicle. And when we got involved and we started speaking to regulators, to lawmakers, to customers, they all started to understand that a competitive data economy can only work if everybody has access to data, if the fleet can control their own data. But they're saying, here is the extended vehicle, what have you got? And so what we learned from this, you cannot just complain about something. You actually have to have a viable proposal. So we needed a viable proposal, a viable construct for saying, no, data can be provided in an open and in a secure manner so that fleets and all market participants can work with that data. And so the neutral vehicle at GEOTAB, we're very practical. We want to use our technology insight to make things work. So it was really getting involved in that discussion with a viable and concrete proposal of how data can be provided in an open and secure manner.
Thank you. Thank you very much, Dirk. And if I could just ask a supplemental, is the key difference between a fleet and a private ownership of a vehicle, and why neutral vehicle is especially important for fleets?
So one more time with the fleet. So data, one data set, your Facebook data is maybe worth $10, and it's not maybe a big deal. But if you aggregate data across a lot of people, data becomes worth a lot more. So especially in the fleet space, the ability to aggregate data by a fleet makes the data a lot more valuable. And then again, the mixed fleet, the idea of that I can run a fleet from various car manufacturers and I don't need one supplied just by one and it locks me out of the other. So the mixed fleet and the ability to aggregate data is really what's crucial to this.
Excellent, thank you, thank you. I'm just going to jump over to Craig, if I can, for a question on open architecture. So as a founder of Open Garages and a true believer in open systems, I wonder if you could just describe and help differentiate an open architecture system versus a closed architecture system that might be what Extended Vehicle is proposing.
Yeah, and from a security perspective, we deal with this question all the time. We always have. So it's one of those things that we've come to learn that over time, it is usually, well, it's almost always better to go with an open system. We see this with anytime there's any kind of complexity or real risk in the data involved, that we want standards, we want things to be open, we want multiple people working together on the same kind of thing. To just take a company and say, oh no, just trust us, we rolled our own solution, this one's fine, you just can't look at it. Whenever I can't look at something, but I have to just trust them, I already have a red flag. And I've even seen this proliferate over time to even commercials. There's commercials on late at night where they say, oh, we use military-grade encryption, which I find crazy to even hear on a late-night commercial. But that just shows how important that has become. And that's an encryption standard, because encryption is difficult. It's usually there to protect something of value. And so those things, it's very important that they're open, so much so that it's even gotten into commercials. And you'll see that time and time and time again. When you're dealing with something that has a large amount of value, like it does in fleet, that's an area that you really want to protect, and you really want to do it right. And it really encourages innovation. It has a lot of other side benefits as well. I'm also a big advocate of open source technology, so working in that area, you have to have a slightly different business model than I'm going to sell you this magic box to something that actually has to be good. And when you do that, it works fine, and those things allow for different types of innovations. Ideas you didn't think of that your customer needed will sometimes come to fruition. Like we're like, oh, this is what they want. And it's like, well, maybe some of them, but then there's this other thing that somebody else wants. And having an open way of communicating, open standards allows for this kind of growth because security oftentimes just isn't static. It's something that just evolves.
Cool. Okay, thanks very much, Craig. And now maybe if I can come back to you, Dan, you're sort of uniquely qualified to talk about security, having the director of security at the University of Colorado, and then previously with Homeland Security being a department head for the security of the telematics implementation under the executive order for all federal vehicles. And so the question comes that, well, can open systems be secure? Because the term open sounds inviting. And I wonder if you could provide some insight on that.
That's a great question. And I would actually turn that around a little bit and not only say, can open systems be secure? Of course they can. I would claim that really only open systems can truly be secure. And we've seen that through the many examples. All you have to do is flip on the news and we might say, well, if I use a closed system to, say, protect the classified personnel information inside the government, or I use a closed system to protect nuclear submarine systems, or I use a closed system to protect financial data from large vendors, all those sorts of things. The examples are ripe by the fact that the closed proprietary approach rarely, if ever, works. As Craig was pointing out, the open approach is really the preferred approach to security. And so why is that, right? One reason is in security, you're playing against an adversary. And almost by definition, the adversary thinks differently than you. Think about this in terms of, say, a sports analogy, right? You'll have a game plan for going against your favorite basketball team, your favorite hockey team, whatever it happens to be. But anybody who's done this knows the other team never plays exactly by the script you expect them to play by, right? You can anticipate as best you can, and that's what a closed system will do. It'll say, I think the other team is going to play like this. I'm going to design the following defenses. But the other team isn't really going to play entirely like that. With an open system, I get a view from people I wouldn't expect. I get other experts or folks who may not even be considered experts in the field, who have really innovative ways of looking at the system, can poke a hole in it and can fix it. And I think one of the strengths of work like Open Garages and a lot of the open systems is that it's not relying on, wow, that person is really smart or that company has put a lot of money into cybersecurity. It's relying on the broader society and broader community to address the right security problems.
Excellent. Thank you, Dan. Any additional supplement to Dan's comments there, Craig?
I mean, one thing that Dan made me think about is I've seen some misconceptions when things are private, where they think, oh, if it's private, I can keep it more secure. And a lot of their security design involves people not knowing how it works. And I think what you don't realize, the bad guys don't play by the rules. They're going to figure out how that works. And then once they know that, if your security solution falls apart, it's no good. So that's one of the other side benefits of having it open. You don't have that delusion that you have this extra secrecy that's somehow protecting you. It's like, well, this is what we're going to do for security, and people can look at that and say, oh, that's good or that's crap right off the bat.
Yep.
And I think if I can add to that, I think that's a fantastic point, because with a closed system, you're not preventing the bad guy from knowing how it works, right? The bad guy can purchase a car. The bad guy can analyze a system. The bad guy can reverse engineer a system. The bad guy can bribe someone within the company to give away a design. Mm-hmm. To say that my security relies on the fact that no one other than my trusted set knows the secret protocol, that's never worked in security terms. We call that security through obscurity, right? And that's not a positive. If you're hearing somebody say, oh, you're just doing security through obscurity, that's an insult, not a compliment. And what you've done by making it closed like that is you haven't stopped the bad guy. What you've stopped are the real users who potentially could help catch a problem. What I've done is I've created a system where the only people who know how it works are the people who designed it and the people who are trying to break into it. All of our users, all of our people who might say, wait, that doesn't look quite right, they don't understand how the system works, and so they're left in the dark. All you've done is you've cut off this massive set of potential good users who could help you troubleshoot the problem. you haven't roped off the bad guy at all.
I've seen studies, for example, someone's done obviously a proponent of a closed proprietary system as far as the number of lines of code in Linux versus Microsoft or whatever. And the number of bugs per line of code, as far as security issues in Linux, the stats-wise is higher. And that's just because of the peer review, that things are found, discovered, and fixed. Where in the case of proprietary, it's just unknown. It's not quantified. It still exists. People with enough time and motivation will look for those things. They'll run it through a disassembler, look at the features and capabilities of it, and they'll think of creative ways to use those against you.
Another great point. So thanks very much for adding that, Ted. So now what we know is that we know what an open architecture is for vehicles, and we know that open architectures can be more secure and can certainly be secure. So now, Ted, World Wide Web is probably the most successful open architecture, right? It doesn't matter what brand of computer you have, you can connect to any IP address and have the services of a particular site. It would be excellent to have something like that for vehicles, and that is exactly the area that Ted is involved with W3C Auto. So maybe, Ted, just if you could give some background on how the W3C Automotive works and what it is.
So undoubtedly everyone's heard about the web. It's been a tremendous innovator. It's been a major disruptor. It's created tons of benefits across industries. And a few years ago, we decided to take different industry focuses instead of just working on the lower level standards. And for automotive, we started off with what's probably the most important and pertinent to this audience is a common data model and method for accessing all the wealth of information that's available on a vehicle. And to be able to expose that in a consistent manner to applications running directly on the head unit. The head unit is your car stereo and a computer combined together. And we, of course, have other things on media and navigation and notifications and so forth. But obviously, the most important for this audience is the signals, the data. And we have a number of OEMs, tier ones, tech giants, companies like GEOTAB, giving us their input and guidance and expertise as far as how we should shape this. What are their problems that's needed, and how do we solve it? How do we go about it?
Excellent. Thanks very much for that, Ted. And yeah, GEOTAB is a recent member of W3C, and it's really exciting to be on the calls with the vehicle manufacturers who are designing the architectures for their vehicles and discussing how to do that in a way to get the vehicle data securely from the vehicle to the cloud in a common format. In fact, on one call, there was a vehicle manufacturer that produced 10 million vehicles a year, and the app developer said, that's nice, but we need all of the vehicles to be on the common platform in order to be efficient with the app development. Ted, I wonder, as a supplemental question, if you could give some examples of the open standards that W3C would have provided for vehicles that would share the kind of work that you get involved in.
So the uses of this data and this information is huge and varied. Our spec work is reaching maturity. It's starting to roll out. People are implementing it. And one example, it's sort of a prototype, a proof of concept. A tech giant, Baidu, and a startup in Seattle, New Sky Security, retrofitted a bunch of buses in cities in China with our specification in order to expose information from this roving fleet of buses around these different cities. And they shared this with me as far as a demo. And I was surprised at the very signals that they're focusing on. And because I thought that maybe they would care about something else, but they had things like air intake, engine temperature, and so forth. And so immediately I said, the conclusion I drew was, oh, you're sampling air quality across the city over the course of time and day based off how rich or lean the engine's running. They said, huh, no, but come to think of it, that's a great use for it. And so then they sort of started involving city planners and so forth. And because it's sort of hard to understand all the potential uses of information until you start exposing it, until you start thinking of different things. They said we just chose those values at random, just for this proof of concept. They said, well, here's a way you can actually use it.
Excellent example. Thanks very much for sharing that, Ted. So we've got the open architecture and the security, and we have the MIT W3C to help develop the open standards. And now I'd like to bring it to Stefano, who is the technical architect for neutral vehicle. And maybe if you could speak to what the next step is, or in the importance of having a prototype of neutral vehicle to demonstrate.
Yeah, absolutely. So if we look at the history of neutral vehicles, so from 1 year ago we were in Brussels and we had the first conversation with the industry, and we have been able to bring to the table representatives of fleet for more than 5 million vehicles. And so we immediately got the interest they had. Our next step has then been showing the neutral vehicle platform to the legislators. And again, the reception that the neutral vehicle had was extremely positive. And one of the main reasons for that is that neutral vehicle is a very concrete approach. So it's not a theoretical solution. It's something very, very concrete. And so the next logical step is to have a prototype that can really show that the 5 principles on which we built the neutral vehicle, how they're going to be implemented. So the 5 principles of security, privacy, openness, scalability, and neutrality has to be explained and tested out. To do that, we will need first step will be finding fleet. So because those are really the ones that are generating the data. Then the neutral vehicle is an open platform. So we've got different type of technical solution to extract the data, collect the data from the vehicles. On this, ideally, we would like to have vehicle manufacturers involved as well. And in particular, we're looking at electric vehicle manufacturers. So we saw in the presentation from Fleet Karma GEOTAB today that telematics is essential for electric vehicles. On the other side of the neutral vehicle platform, its value really comes from the application and services that will be built on that platform. As GEOTAB today, we've got over 100 marketplace partners that have already built a solution with us, and they will be again essential for the neutral vehicle. So we need to provide concrete examples of applications that are useful to the drivers, to the fleet owners. And the last step would be the socioeconomic benefit that the neutral vehicle brings. And for that, we need to have local authorities, universities, so all those stakeholders that can really leverage the data, especially the anonymized data that we are collecting through the neutral vehicle platform. So key will be having all these stakeholders together so that we will really be able to show how real the neutral vehicle platform is.
Stefano, you're really stressing the point of collaboration here. And I'm just wondering, Glenn, I mean, you have been collaborating a lot. Maybe we can hear a little bit from you what that collaboration with bringing all these stakeholders together, what that really looks like.
Sure. Thanks very much, Dirk. So that was one of the first tasks that I got involved with when I joined GEOTAB, was to get involved with the Society of Automotive Engineers and the meetings that they had on cybersecurity and standards, and began to recognize the community in this space. And maybe the best example would be GEOTAB had brought in a consultant on security, had implemented some security architecture, but how do you know if it's great or not? And I happened to be at an SCAR conference in Detroit, cybersecurity, and I got a text on my phone that there was an article in the Globe and Mail that was quite critical of OBD devices being attached to vehicles. And the author of that article is with us today, Craig Smith. And I walked over to Craig at the conference and asked him about this. And he said, look, my experience has been the ones I've looked at are not secure. If I looked at yours and it was different, I could change my mind. But that's the way it is now. And so that began our relationship. And we got Craig some devices, and it took a little bit of a conversation with Neil first. And then he banged away and sure gave us recommendations, but it was fairly solid. And then we applied those recommendations. But the key in collaboration is aligned interests and transparency. So then when we began working with the executive order in the US to get certified for the federal vehicles, we shared those penetration test results with the Department of Transportation, Volpe, and this is where I got to meet Dan. Well, that was a very unique experience for these folks, because up till then, anyone they had talked to was holding their pen test results very, very tightly. And so through that collaboration, then there was trust and transparency. Those are sometimes interchangeable. And so we start forming a group with an aligned interest that isn't looking at the next quarter's profit statement, but looking longer term. What's the best for society? And if you have that view and you have aligned interests from those people, that got me to meet Dan then. And I could keep going on, but eventually, I mean, the Department of Transportation, Volpe Research Center, I'm in daily, weekly communication with. Then he introduced me to Ted Gill and said, I think you two have aligned interests on what neutral vehicle and security ought to be. You should get together and have a chat. And we did. We had aligned interests. And so we've formed a working group of experts that are at the top of the field in the neutral vehicle platform. And now we're finding that senior authorities are coming to us for expert opinion on a variety of topics, which is really rewarding. And that's a part of the collaboration story. Yeah, it's about aligned interests, transparency, and looking beyond the next quarter, financial results. So thanks for that, Dirk. I'll just move on to the next one. So, Dirk, if I can come back to you, one of the questions that comes up, I mean, it was alluded to this morning, is just who is it that owns the data that's generated from the vehicles? And I wonder if you could provide some commentary on that for us.
Sure. This is a great day and age to be a lawyer, right? Because the question of who owns the data is on a lot of people's minds. And it's amazing how there's an expectation, yeah, here's who owns the data, but the question is, in what jurisdiction are we? Are we in the United States? Are we in Canada? Are we in Europe? Are we in China? What data are we talking about? And so the question sounds simple, but is of course very, very complex. And so let me give you a little bit of my perspective from what you would consider the Western legal tradition, somewhere between common law and civil law, who actually have a very similar outlook on the concept of data ownership. So first of all, there is no data ownership law anywhere in the world that I would be aware of. So you have to fall back on existing legal concepts when it comes to owning stuff, which is property law. And so we have real estate laws, who owns the house and the condo. But it's clear that data is not a house and a condo, so we can't use those. Then we have, who owns this bottle, tangible property. But again, Data I can't touch, I can't hold, so tangible property laws don't apply. So now I'm with intellectual property laws for intangible property, but copyright and patents and trade secret all assume that you apply some creativity to the data, so that doesn't fit either. So after all of that analysis, the brutal reality is that nobody owns the data, and nobody really should own the data, because data, raw data, is what happens. CNN doesn't own the news. What happens is what happens. Now, they make a lot of money off the news, but they don't own what happens. And so that is really the starting point. And it also goes back to what Neil was mentioning this morning. The beauty of data is not if I have it, you can't have it. No, I can use the data, you can use the data. And so the reality is property laws right now do not apply to data, and I don't think they should apply to data. Now, that doesn't mean I can access anybody's data just like that. I have privacy laws that protect my data. My passport number is my private information. It is protected. Now, I couldn't sell it to you, so that shows it's not property, but I can keep it private from you. So we have privacy laws that protect data. And then we have computer interference laws. So if I own the computer, you cannot just access my computer. And if what we learned this morning, I own the car, if the fleet owned the car, then I'm the primary person who can have control of and access that data. So while we do not believe there is really ownership of data, unless you apply intellectual property and creativity to it, the person who owns the data generating device, in our case what we're talking about here the car, is really who economically controls what's going on, but also has to respect the privacy of others. And so that's an important starting point, but then there's contract, right? End user license agreements may say a lot about data ownership, and so what we've done at GEOTAB, the first thing we put into our end user agreement, we don't own the data, and you can really see hear the collective sigh of relief of people who read that. But everybody here has to be aware, while we think nobody owns data, there are a lot of people who think they do. The vehicle manufacturer thinks I built the car, so I own the data. The wireless carriers, present company included or excluded, say I transmit the data, so I should own the data. And so it goes. Anybody who comes in touch with the data thinks they own it or should own it, and so it's good to read the end user agreement and to go back to, you need to be sure you can use the data that you have, that if you own the data generating device, the vehicle, that you protect that, and then that you collaborate on that basis as much as possible. To us, the question of interoperability, can I access the data? Can I get to the data, is actually much more important in my view than the data ownership question. So data is about data security, we talked about it, it's about data privacy, and then it's about data access, which is mainly a technical question of interoperability and not so much a question of data ownership in a property law kind of sense. Great time to be a lawyer, Glenn.
Yes, that is a complicated question, and it's like peeling the skin back on the onion a little bit, but thanks for a very thorough answer to that question, Dirk. That was great. Was there something you wanted to add, Dan?
Well, I would just say that, I think that the data access and the security and privacy for that data access is critical. And so, touching on two things that were talked about. So as Glenn was pointing out, there was an interesting shift that happened in the US federal government within the last few years. We went from the world where we used to say, you know what, that federal vehicle, especially say a sensitive law enforcement vehicle, they were physically taking out transmitting devices. Stuff that might have collected and reported data was physically removed from the car. Now, that was happening when I initially started at DHS. By the time I left, it had made a complete 180, and there's, as Glenn was alluding to, there's an executive order that's a few years old now that says you actually have to have that vehicle online, including those law enforcement vehicles. Now, there are some law enforcement exceptions, but for the most part, that vehicle went from, I want to make sure that there's no data coming off the vehicle. That's not really possible at this point. And I want to make sure there's no access to that vehicle, to saying, all right, I have to make that data online. I have to make that data available online. And one of the one of the strangest meetings I sat in at the government side was somebody who's almost certainly not a vendor in this room, but they came with a great solution for a federal law enforcement agency to say, hey, we will solve your data problems. We will make your data available. All you need to do is take this approach. And they showed us a great demo where they started by logging in, and we all noticed, because we're security people, we all noticed they logged in with a 3-digit password into a website. And with that 3-digit password, they said, if this had been your agent's car, we know, and in their case, it was a car that was on loan from the government, so it's effectively a government car being used by the agent. They're like, I know when the agent left his house. I can see here's where the agent dropped off their kids at school. Here's where the agent dropped off the dry cleaning. Here's where the agent arrived at work, all with a 3-digit password on the line, right? And so what they were trying to do is they were trying to sell this as, this is a feature, boy, don't you want this? We're all sitting in the back saying, wait a minute. So now I know where the agent lives. I know where the agent's kids go to school. I know what the agent's routine is like. It's protecting, it's not about owning the data, it's about the access to the data. And the access has to be secure, and it has to respect privacy. And whether it's for an individual or for a fleet, like a federal fleet, ensuring that security and privacy is really critical. And I think that's some of the stuff that's happening with an open platform that I can say, okay, I understand what the security issues are, I understand what privacy issues are, and I'm addressing them rather than coming with what the vendor thought was an amazing demo, and what all of us in the room thought was, oh my goodness, we must never deploy this on any federal law enforcement vehicle.
Great. Yep. Thank you. And that leads nicely into Craig is author of Car Hacker's Handbook. Can you sort of describe to us how one might hack a car and how that has changed over the last, say, 5 years in terms of how difficult it might be or easy?
Okay, well, this is a rather large question, simply because there's lots of different ways to hack a car, and you have lots of different intentions when you're hacking a car. So depending on who the hacker is in this particular case, we have some very innocent, very do-gooder states where you're just trying to modify a car, you're a performance tuner, you just want to make something different, you have to reverse engineer it, or maybe you have to get some code onto the infotainment center. Those kinds of hacks are one thing. I assume you're referring to more of the malicious style hacking. Maybe not, I don't know. Mm-hmm. But if you are, we typically look at things like the cellular networks and whatnot to gain access to the vehicles. Bluetooth's another one. So we usually go from wide ranges inward. And in the past, well, not in the past, really kind of in the present, the vehicles today are not too difficult. They were designed at least 5 years ago, before they even rolled out, like the 2018 models were designed 5 years prior to that. So there wasn't a whole lot of, thoughts around security at the time. There definitely wasn't any standards from that such type of thing. And so figuring out how they work is pretty easy. Getting your code on there is pretty easy. As we get to like lane guidance assistance and that kind of stuff, not the full self-driving cars that we talked about earlier, not the level 4, level 5, but the ones we're currently doing where it just kind of keeps you in the lane and sees things. Those are relatively easy to manipulate simply because it's a trusted network. There's not necessarily security there. There's no reason to trust it. It just is. So if a sensor says, oh, I see something in front of the vehicle breaks. So as an attacker, I just got to either fake the sensor seeing something, or I send the message saying, oh, you saw something, you should brake. There's no checks and balances at the moment. And when we get to class 4 and class 5, there's checks and balances because you have multiple different types of sensors. They're making a better decision on things. Right. So if a sensor says something odd, the other sensors go, yeah, it's not really what I see. And that actually becomes much harder as a hacker. And there's this weird kind of push now, almost at as they kind of had an awakening, like, oh, we can hack a car and we can control a car. They kind of went to this point where they're pushing really hard. This is the automotive manufacturers to try and lock down the car. And through this effort, we seem to be going to some things that are, from a security perspective, maybe a little bit better. Like we hear encryption, you hear some of these words we're used to in security. but they're using it to silo themselves off a lot of times. It's not really necessarily fixing the root of the problems. They're just trying to lock people out from looking at the problems. And so I'm seeing this like, oh, we can't allow anybody to do anything with the vehicle because safety. And it's just this generic flag you throw up, like, oh, no, only we can have rights to this, safety. We encrypt everything now. And that's not a way that's going to really help fix anything. It's just going to add an extra barrier that's not going to stop the attacker. I think there's still some learning that has to be done.
Cool. Yeah, and the other thing that I had picked up from some of your workshops was just how much of this has become available on the internet in an open source for individuals versus 5 or 6 years ago, the tools weren't nearly as sophisticated.
Yes.
A lot of sophisticated tools available, and the bad guys seem to do a pretty good job of sharing. And
I guess I'm the blame for a lot of that too. Yeah. After writing a book on, I guess I'm the blame for some of that.
Yeah.
Books
Well,
open source and some tools,
but hence the Auto ISAC formation. So the good guys share their information as well, and GEOTAB is a member of the Auto ISAC and participates in that. Mm-hmm. Thanks very much. And maybe just on that theme, I'll maybe circle back just quickly if I can, Dan. When you were with Department of Homeland Security and you were looking at cybersecurity risks with vehicles and heavy trucks, can you name a couple of the different types of risks that you were especially on your radar screen for high risk on cybersecurity?
Sure, absolutely. So obviously, like we kind of alluded to, one risk is simply gaining situational awareness about the vehicles. So perhaps if I can find out where where that agent lives, where the agent drops his kid off for school, that kind of thing obviously could be a concern. But it extends across the whole vehicle, and from demonstrations that we've hopefully all seen. If you haven't seen, Google car hacking. There's a lot of fun videos to anywhere from taking control of the car to simply gaining information about the car. Our biggest fear was this occurring, in conjunction with some other event, right? So if you had an incident, whether it was a planned incident by some malicious actor or whether it was an incoming a hurricane approaching or a natural disaster, we could predict ahead of time. If someone could cyber sabotage our first responder vehicles, some of the solutions that might make a lot of sense in other contexts actually work very badly in the case of some government vehicles. So for example, you might put your car in quote, a safe mode if you feel there's something going on. And so the car then can only drive up to, say, 20 miles an hour and is limited in the controls it can do. That might be great for my car. That's the last thing I think I want to have happen to all my Toronto police vehicles, to say, hey, we're in safe mode. And also, just to touch on one other thing about Craig's demos. So if you haven't seen one of them, it's really worth doing. There's some great open source ones. We attended one in I think it was in Orlando at ACSAC or somewhere. And so when we talked about the security through obscurity back at the beginning, to say, maybe what I'll do is I just won't tell anybody what all those secret codes are. And as we were pointing out earlier, that's not going to stop the bad guy from figuring them out. In fact, we took, with Craig's permission, we took one of those demos and we did it with a set of middle school kids, so 12 to 14-year-olds. And they were able to reverse engineer and do some of the great exercises like pegging the speedometer at 120 miles an hour, unlocking the doors. And so this wasn't a set of, incredibly well-trained, spent 5-6 years analyzing vehicles. These were 12-year-olds. And the 12-year-olds were able to reverse engineer a system. So it comes back to that, let's be open about it, because otherwise, the 12-year-olds can get in and the real security, the people responsible for security can't, right? And that's what we need to, that's where an open standard does so much better, because, hey, if the 12-year-olds can reverse engineer it, and the other thing that I think, as a positive toward the vehicle manufacturers that has been working well, is there are concepts that if we have an open design, we can use, like separation of systems, right? So So security through obscurity, saying only I know the code, that doesn't work, that's provably doesn't work. Things like separating safety critical systems and infotainment systems, building separation into our architectures, that actually does work, and that can protect my vehicle, my first responder vehicle, any of those. And that's the kind of thing that something like a neutral vehicle standard tries to build in and tries to incorporate across the board.
Cool. Thanks very much, Dan. Ted, with the W3C Auto Group, it's primarily vehicle manufacturers and some tier 1, tier 2 suppliers and GEOTAB. For others that would want to get involved with the W3C open standards, how would that work? How could others become participants in that process?
So the way good standards work is to get a broad, diverse range of perspectives. We do something that only has auto manufacturers present, only solve their needs, their purposes. So we need to make sure that we're solving aftermarket needs, the people that are working on distracted monitoring systems, some of the ADAS systems that I'm sort of seeing in the premier presenters in the back, having walked through there, including 12-year-olds. To a certain extent, you should never underestimate the mischievous. You know what I mean?
Yeah, we are.
It's some dry line. But also the sort of the try for a joke and it falls flat. But the mischievousness, no, that's not the right word. Moving on. But also the sort of intellect and the sort of intuition and just collection and bringing together of good and bad ideas and making sure that a solution sort of answers this broad range. I've referred to standards development as herding cats. You need to get some haphazard group of people that have very different interests, some commonalities, to look at the problem from understand their different views on that problem. And in doing so, you come up with a more solid solution. And that's what we could really use from the GEOTAB community is some of these perspectives. I mentioned like ADAS and distracted monitoring systems. We're missing that in our vehicle signals data model at present. We have talking with a couple of tier 2s that are creating products in that line, and they're hopefully going to be contributing to that, but your aftermarket partners can as well. So love to hear their perspective.
Excellent. Okay, thank you. And Stefano, you're director of Europe. You spend most of your time in Europe, but you also have good visibility in North America. So I'm wondering if you could provide some comparison as a fleet manager to the view of the marketplace in Europe versus North America with telematics with respect to neutral vehicle, the access to data, security, and privacy.
Yeah, so I think as GEOTAB, we've been in a very nice position where we've got activities on both sides of the pond, and we've been experiencing the differences in perception in the two markets. So from my point of view, if we look at North America, the discussion around security is way more sophisticated and advanced in US and North America. So when we had Professor Massey coming to the European Parliament and really bringing this concept that security through obscurity is really not a viable option, that was really an eye-opener moment for several people, several legislators in Europe. And if you look at the activities that have been starting from the DOT and NHTSA that have tasked the SAE working on committees like the hardening of the OBD port, permanent devices connected to the OBD port. So you see that the level of discussion has been way more advanced here in North America. But at the same time, if we look at Europe, 2 weeks ago we had GDPR coming into effect, so the General Data Protection Regulation. And so GDPR has been the effort of the last 6 years for in Europe, and really the goal is to put like the driver, the vehicle owner, back on center stage. So he is really the data subject in a more technical terminology. And but I see many similarities actually with the security side. So transparency is the most important thing on privacy as well. And so GDPR is really based on transparency and consent. So if we are now moving in a new economy driven by data, we need to raise the bar also on the way we manage data. And I think GDPR and all the work done in Europe around data privacy is really something that is providing additional value for the neutral vehicle platform as well.
Cool. Well, thanks very much, Stefano. We've got just a few minutes left, so I'd like to turn it over to you, Dirk, if you have some concluding comments for what individuals and organizations can do next to get involved.
Yeah, thanks, Glenn. And really, if we could have a look at the next slide here for the production team, or you can do that, thanks, is it has been said that data is the new gold and it's a new asbestos, right? So data can be a huge benefit to a business, but it can also be a huge problem. So that's why security is so important, but that's why understanding what data can do for you is equally important. And if you look at, if data is, if we stay with the analogy, the new gold, and how much effort we spend to exactly know where our money is, then we should spend that same amount of effort, where is our data, and how do we have access to that data. And we need to let lawmakers and we need to make policymakers know how important that data is to us. And so brought up here the logo of the Global Alliance for Vehicle Data Access, which really has the mandate and the mission to create awareness of the importance of transportation data for everybody's business here. And so if somebody wants a very concrete takeaway, what can I do as a result of all of this? Having listened to this discussion, you can go and see Greg Scott. Greg is the Executive Director of GAVDA. He has a stand right there. He has a brochure, and so go and see Greg and let him know that data is really important to your business. And then Greg is very effective with GAVDA to make that message known where it needs to be heard, and that's in Washington and that's in Brussels, to really have the awareness of the importance of data to everybody's business here, to be able to compete and to innovate and not end up in this supply managed data world. So that would be the ask here from us to you, is to go and see Greg, pick up the brochure and take an interest with what's happening with data.
Great. Thanks very much, Dirk. And with that concludes this panel discussion. So enjoy the rest of your Connect afternoon.
Okay. Thank you.